So hello everyone, thank you very much for joining the Stellar workshop today. This is the second Stellar workshop of the Hack the System hackathon, and today we're going to be covering how to build a Stellar wallet and a few of the other kind of support that you need for building on Stellar. So in terms of the kind of schedule for Hack the System, this is the final week of the learning phase, the final day actually, as it is Friday, and sort of starting on Monday, the build phase begins. So we're really excited to see what people get to building over the next 5 weeks before the submission date, which is on May the 2nd. In terms of submissions, we should have an article released about next week about the kind of specifics around submission. So make sure to keep your eyes peeled for that. Okay, I think without further ado, we'll hand over to Tyler, who is the ecosystem developer evangelist or ecosystem evangelist at Stellar, who's going to give us the workshop today.
Thank you very much. Super excited to be here. My name is Tyler Vander Hoeven. I am the ecosystem evangelist at the Stellar Development Foundation. Last year, I wrote a long format tutorial on how to build apps on Stellar. And that's what we're going to be walking through today. Before we jump too much into code, I'm going to cover a few docs and links which you'll want to write down and get access to, and then we're going to jump right into the code. Hopefully we've had some time to look through a little bit about Stellar already, have some background knowledge, and now we have the freedom to jump straight into the code. First thing I'd like to cover is this GitHub repo for our building on Stellar. It's got lots of great links. This will be your kind of launch pad for all things Stellar tooling. So as you build applications is where you're going to want to go to find the laboratory or Stellar Expert or the different SDKs that we have. So that's a really important one. So if you just go to Stellar and then type in a keyword hackathon, you'll find this hackathon get started repo. So that was super important. Next one is, this is the repo we're actually going to be working from today. So you'll either want to bookmark this, you can go ahead and clone it right now if you'd like to. We're not going to do too much pair programming with the size of the group that we have. We just won't make any progress. So you will want to get this repo though, because this is what we're going to be working from. But notice that we will not be working from the setup branch, which is our default branch. We're actually going to be working from the trust line branch today. So feel free to jump in, clone this if you'd like. This is what we'll be working from and explaining, so you can kind of walk through, be set up with the code that you need. Don't worry too much about following along unless you're very quick at coding. You can always watch back through this workshop. All right, so the Stellar wallets, where this building apps. When it comes to building applications on top of Stellar, there are public APIs, our network. So you've got the core on the one side, which is doing all the transaction processing, putting the next block in the ledger, et cetera, et cetera. And then that produces a whole bunch of data, which then makes its way over to this sort of human readable interpreter engine called Horizon, which is our public API. So you've got all these nodes that are running core, and some of those nodes also run Horizon endpoints, which then digest or deconstruct those blocks into this sort of human readable or machine readable JSON API endpoints. And that's what we're going to be accessing today. All of our SDKs interface directly with those public API, that Horizon endpoint. So when we talk about building applications, we're talking about this sort of user interface that's directly connecting with or interfacing with those Horizon APIs. So if we were to go to something like our laboratory, you'll see that up at the top here, we've got these different API endpoints. These would be different Horizon API endpoints that as you start to build transactions, sign transactions, submit transactions, those are going to be interfacing through a REST API endpoint that's based off of these Horizon endpoints. So if you were to like copy this and go here, you can see this Horizon endpoint stood up with some of the just stats about it, what version it's running, different endpoints that it has, et cetera. We're not going to get too much into the actual Horizon side of things other than just interfacing with through our SDKs, but just understand that we are actually interacting with either the live public network or the test network. Today we'll be doing test network, but the only thing you have to toggle between testing and running something in production is just that Horizon API endpoint. You're not going to have to set up nodes or have a big machine in the background processing transactions. You can just grab one of these Horizon endpoints that's connected to some service provider that's running this version of core and begin to interact directly with the ledger, whether that's reading transactions, posting transactions, etc. For our wallet tutorial today, we're going to be walking through this. If you go to developers.stellar.org, it'll pop you into this docs page. And then on the build apps overview section here, we can get started building our app. This actually goes pretty deeply into depth into lots of different interactions. We're going to make it about through handle custom assets. And we're just going to dive right into the code and start looking at the different methods and functions. If you're getting lost or you want to kind of get a very verbose written instructions on this, this is kind of what I'm basing this video off of. So feel free to go back through and read these in depth along with all of the code that's being included. So I've already got this repo, this Stellar Docs repo or wallet, a Docs wallet repo pulled down. So I'm going to pull over my CLI, right here, and we're already in this directory of the Docs wallet. So you'll want to clone that, pull that down, get it wherever you want it to be stored, and then we're going to run our npm install, which will get all of those dependencies installed. That'll also do like a little linter and ensure that the build actually passes. So hopefully that'll pass without a hitch as you install those. Again, if you're getting stuck there, don't worry about it too much. We can address some of those questions later, or you can jump into our Keybase or Discord dev channels and ask any questions, or just make an issue on the repo. From here, we're going to be spending most of our time in the code. I'm actually going to go ahead and start this up, npm start, which will create a local environment where we can run this application in our local environment on localhost 3000. So I'm going to go ahead and walk through some of the functionality that this app's kind of whet our appetite a bit. This is the interface that we're going to be constructing. We've got just this very basic create account. The whole account system is protected by a PIN code. I'm going to, enter something super secure here so no one can hack me. Do that again. That's going to go to our blockchain in the background. It's going to create a key pair, one of these public-private keys, most of blockchain, but the Stellar blockchain takes advantage of the private-public key pair system. So you've got a public key and then a signing key, a secret key behind this, where you can sign all of the transactions that you're going to be making, or the modifications, the mutations to the ledger every time there's a new block. So those instructions are signed with our secret key, but the public key is fine to go ahead and share. And then it pops up this interface. So if we were to take this address, just to prove to you that this is actually on the, we've actually made an account. We've funded it with 10,000 test lumens. We can go to the network here, explore our endpoints, look up this account, make sure we're on this test network, look up a single account, put in that public key that we just created, and you'll see that in fact we have that account. We could also go to something like Stellar Expert, which is a blockchain explorer for Stellar. Go to the test network, put in our public key, and sure enough, we've got our 10,000 lumens. So count is showing up everywhere that it should be. And now we can begin to make payments or trust assets. And this is as far as we'll get. There's lots of other things that you can do. If we were to look at our build transaction capabilities, we got all kinds of different operations that we can do, and you can also combine these. A single Stellar transaction can hold up to 100 different operations. So there's lots of interesting and fancy things you can do within an individual transaction. For our cases today, we're going to be focusing on making payments and trusting assets. Trusting assets, that's kind of if someone were to create a custom asset or issue their own asset, this would be the concept of trust lines. And we'll get into that in a little bit, but let's just go ahead and really quickly make a payment. I'm going to pull in this other window here, my my Safari window, and we're going to create another duplicate account. So this is going to make another one over in a different window so that we kind of have this idea of two different wallets that can interact with each other. So I'm going to make a payment from this account to this account. So this guy's going to say, hey, send me some money. So we're going to make a payment of 100 XLM to this destination address, which is the one we just copied from over here. We'll need to sign that transaction by decoding our key store with the PIN code. That'll sign that transaction, package it up, send it off to the blockchain to make that payment. We can see we've lost that 100 XLM minus also decreasing our fee, that 100 stroops. And then if we update this account, we should see this increase to 100. So there we go. We successfully made a payment. What about trusting assets? So the way that assets work in Stellar is you don't really create yourself a balance of something that somebody else then gets a slice of. Individuals or users or really accounts will trust your account for that asset. They will say, I am willing to accept this particular asset from you. So rather than you creating a balance of something in your account and then issuing it out, other people interact with just your address and say what they trust from you. So in this case, instead of starting from here and saying, send this account something, this account, before it can do that, has to say, I'm willing to accept something from you. So it's going to say, I accept, I'm going to copy this account. I accept pizza tokens from this account. And sign that. And you'll notice once we send this transaction off, this also makes it to the blockchain, which says I'm willing to now accept this pizza asset from this account. Of course, at the moment, I don't have any. And now this account can make a payment, but instead of it being XLM, it's going to be pizza. So let's send one pizza to that account. Who is the issuer of pizza? I am the issuer of pizza. And that me there is just a short code for putting in the public key, so I don't have to copy it again. Decode my secret key, sign that transaction, send it off. We refresh this. We should see that we have one pizza. If we were to copy this and go into something like our blockchain explorer and open up this account, we'll notice that this account has a pizza, as well as the lumens that were sent and the operations that made those up. You could explore those individual operations, which were inside of individual ledgers, all of that publicly available on the blockchain as we're doing it inside of our interface. So that's all well and good, all very fancy. That's kind of a nice look through of what we're going to be building. So let's jump into the code. So the wallet here is created in a framework called Stencil.js, which is quite similar to React in many ways, put on by the people that build Ionic, which I'm a super big fan of. It doesn't really matter the framework you use. I really like Stencil just for doing examples because it's quite low level, so you don't have to learn a whole bunch of React or Vue syntax. You can kind of just get right into some TypeScript classes and functions and begin building an application. So it obfuscates away a lot of framework specific stuff and just leaves functions. You don't have to use Stencil.js to build your wallet. You could just extract the individual functions that we'll be looking at. So there's some settings and configuration files here. We don't need to worry too much about any of those. The main thing that we're interested in is our source directory. And then we'll start index.typescript is just importing all of our components. Our HTML file is loading in our custom component, which is this wallet component here, which we'll get to in a minute. And then any additional, like we're pulling in a reset style sheet, some just really basic padding, stuff like that. So nothing fancy going on there. We've got our declaring all of our types for TypeScript, which this actually gets auto-generated, so don't have to touch that. Services, directory, we'll get to that in a minute. I'm going to go ahead and open up some of these just so that we can walk through it. We're going to keep these closed for now because they are more just helpers, which don't have anything to do with the wallet necessarily. There's a loader, which you saw that little pixel window, which is that modal that comes up. Nice tools, but not Stellar specific. So we'll start in our wallet.typescript file. It's a very simple class here, which everything originates, all of our interface originates out of this singular component. This is what gets exported, and then you can pull in with your custom component. We've got all of our different packages getting imported here. Set up our namespace. I'm sorry, this is the Stencil.js. We need to be in this one here. Put all our packages in, set up an interface for the Stellar account. This is basically setting up a class declaration so that I can make sure when items are getting added to account, just kind of TypeScript type stuff. Same thing with the loading. So we ensure that we have all the correct loaders available so that we can show those nice interactions. Include any styling. So there's a little bit of styling going on, as you saw. Won't worry too much about that. And then we get into the actual class of our wallet. So there's a couple of different states. States in Stencil are things that are mutatable that will alter the state. So when these are changing, it will force a refresh in the DOM window. So once we have an account, something might change. If we set a prompter to have some content, something might change. So it's items that will change, that when they're changed will force a re-render in the DOM window. Properties are not that way. Those are kind of just static assets which aren't intended to change, but then will be available throughout the rest of the component. Got some basic events for the component, which we reset down here, which we'll take a look at again. All of our methods, which we'll take a look at one by one. So we've got that set up. I'm going to look at these services just real quick. There's some storage stuff where we are storing items so that if, for example, I refresh the page, it'll pull me right back to my wallet. So it remembers this key store that I put in. So I've got a little storage item set up that in the background is just using local storage, but there's a nice little interface that the Stencil.js capacitor makes available to me. So I've set up a little service for that, and then also an error service just to make it a little bit easier to handle errors throughout the application. If things come back from Horizon, like the account hasn't been funded or they don't trust this asset. And a good example of that would be, let's say this account has not, we'll try and send them an asset that they haven't trusted yet. So if we make a payment of 1 rock to that account and I'm the issuer, decode that, and we try and send that to the blockchain, it's going to say, hey, they don't actually trust this asset, and it'll spit out a nice error that we can take a look at. So that kind of that decrypts that or decodes that error and then shows it to the interface. Okay, now let's get into some of these events. So when we're in Wallet, we've got these two main events. One is render, and if you're coming from React, that should be pretty familiar. It's essentially what is the HTML of this component, and the component will load is an event trigger that says fire this function right before the DOM window is loaded with the HTML. So we'll start there. There are some properties and I think also some states here. These 3 properties in particular, where our server is getting set, that's getting set to the Horizon testnet. That should look kind of familiar, actually identical to this laboratory string. So that's basically saying I would like this whole thing to run inside of the test network. If we removed testnet, this would be a live application, and that's all you have to do to toggle between test and production as far as the Stellar side is concerned. We've got a home domain, which is, we're not going to use that too much today, but if you're loading up TOML files, which are like metadata on top of issuing accounts, so accounts that are issuing assets will set up a TOML file, which basically says, I am this entity, I have these assets, you can trust me because I'm proving domain ownership, but allows all this this metadata to be added, which may be mutatable. So it's not actually put on the blockchain, just the home domain would be. So this is essentially saying this is the home domain that we're going to assume, which is one of our demo test anchors which again, we don't have to worry too much about that. And then we load that up. The toml file will actually look for it, load it up, put it into that toml object, which again, I'm not going to fool too much with those, but they're there. This is the if statement that selects if there's a key store. So this does the get, which is calling that storage service that we had right here. It's going to look for a key store file. And if the key store file exists, it's just going to go ahead and load up the account with that public key in the key store, which we use the pin code to decrypt. So this is essentially whenever I refresh the page before showing the interface, look at the storage, and if there's a key already there, go ahead and load that key. If there's not, then show the create account button or interface, which we'll see when we get to our render. If there's any errors in any of this, we throw that error. Next up is our render.tsx, which has our very basic HTML setup. We've got this prompt, which is this guy right here. So if you do something like copy secret or one of our interactions, it's this modal window. So we set up a prompt with any instructions that need to be sent to it. And then if there's an account, we're going to show account information. Otherwise, we're going to show the create account button, which we'll go ahead and sign out here so that we get back to that state. If there's an error, we show that error. If the account has a state, so when we load up that account from the blockchain, if there's any information about that account, we're going to load that into this pretty JSON stringified account state object, which we can see if we look at like this single account here. So this guy right here, if we load this up, it's just a GET request. So you can see this nice object here. This would be that account state, which we'll look at when we get to the update account method. But basically, we're just going to load in a pre-tag with that object displayed beautifully for us. Finally, if there is an account, we're also going to include some buttons. One of those buttons will be to update the account, and the other one will be to sign out. So essentially, we're just setting up based on the state of those different states here, account information, prompter information, loading information, error states. We are going to alter the state of this DOM, this HTML component. So let's start at the very beginning with creating an account. So all of these things, you can see we're using this.createAccount, which originates from our different methods here, which are all held inside of this methods directory in the wallet directory. So we'll close all the rest of this stuff so we have a nice look on that. And the first one we're going to look at is create account. So when we click this button, I'm going to go back to my render function here. When we click this create account button, we're going to fire this on click event, which is going to create an account. Okay, very good. First thing we do is we don't want this button to do anything except what we tell it to do. So we're going to prevent the default action. And then we're going to ask it for 2 pin codes using our prompter. So we have a prompt method here that's set up on the component. And then we're going to send it these instructions of enter a key store pin code. And then we're going to enter it again. We have an await function because the set prompter returns a promise that essentially allows the DOM to hang, the interface to hang until there's some data or there's some response from our prompter, and then we'll move on to the next line of code. So get a pin code 1, get a pin code 2. We're going to make sure they match. If they don't match, we're going to throw an error of invalid pin code. Let's go ahead and do that now. 1, 2, 3, 4, hit OK. It should go to the next one, enter the pin code again, 1, 2, 3, 5. Those don't match. We should get that thrown invalid pin code error. If they do match, this line won't throw. We'll move into there is no errors. We'll set up a loading, and that loading state is of fund true, which we'll notice if the loading state has has a Boolean true of fund, it's going to set the class on this button to loading, which then triggers this button to show that loading animation. And so that's going to fire off. We'll get the loading animation started. Then we're going to generate a random key pair. This is where we get our Stellar key. So this is the first instruction we got that's Stellar specific. So we pull in this Stellar SDK. We're going to pull in this key pair class, this key pair method, and or key pair class, and we'll call the random method on it, which is going to get a random key pair. I think it's worth mentioning, if we go to Stellar JS docs, we can go to our GitHub pages here and actually look up, let me make that a little bit bigger. See our key pair class, and we're calling random on it. There's a function here. Key pair random creates a random key pair object. So this, if you're using the the JS SDK, this is going to be your lifeblood here, this documentation. So you can just kind of search and find things in the documents. It's of the class keyPair.random. So that's what we're going to call. It's going to load it into this variable. And the next thing we're going to do, because we're on the test network, this won't work, obviously, for obvious reasons on the public network, but on the test network, you can actually call this a little helper service to load up this new account with some test lumens, with 10,000 test lumens. So that's what we're going to do. After we get our key pair, we're going to call keyPair.public key. So if we go back here, we can see there's a public key method on the key pair object. So once we have a key pair object, we can call .public key on it and get the public key for it. So we send friendbot that public key, and this service will give us 10,000 lumens. We're going to go ahead and do that. After that account is funded, we'll set our loading of the fund button to false, because we're about to load up our account object, which, if you recall from back here, once we have an account, we're not going to be showing the loading button anymore. We're going to be showing the account HTML elements. And inside this account, it's an object, and it's going to have these items. If we go back to our wallet, we'll see this class declaration, interface declaration up here. It's going to have a public key, a key store, and a state, which I don't know if we're actually loading in the state yet, but it's optional. So load in the public key, which we'll already know is that right there. And then we actually pull in the key store. So there's an encryption library called SJCL, which allows us to use a PIN code to encrypt a secret key. And then I'm also attaching some data to it. It's worth noting this is a really insecure way. If your PIN codes, which tend to be short, are short, it would be very easy to brute force if you accidentally leaked this key store file to someone, or somebody got access to it. Sure, it's encrypted, but with a 4-character PIN code, it'd be pretty easy to brute force what the actual secret key is. So it's not good to just do a raw here. You'd want to do some PIN code stretching. So that would be something to write down if you want to write an interface that's actually generating wallets on behalf of users, and you're using some sort of encryption. If the PIN code is short, or if the password that they're using to guard that is short, make sure to do PIN code stretching on that. I'm not going to do that right now because it unnecessarily overcomplicates the process of explaining it, but it's worth mentioning that as a good security measure, if you're generating wallets on behalf of your users, whether that's client side or server side, if for any intents and purposes the encryption key is short, make sure to PIN code stretch that. Then we also include some public information. This is information that will be available. So this key storage spits out a string. It's a base64 encoded object string that will be used to decrypt, once we have the PIN code again, the secret key. But part of that key is actually some public information about our account, which is this public key, so that I can have information about the public key, even if I don't have it decrypted. I can't sign anything with it, but I can at least know what the public key is. I don't necessarily think that's a requirement, but it's nice to know that you have the ability to add some public information onto this key store file. All right, so that loads up our account, which will then put us into the state of seeing that account. So right now we're in the create account screen, but The next step after we load that in is to put that new key store file, which is what this account.keystore is going to be. We're going to put that into the key store after we base64 encode it. Or I'm sorry. Yeah, base64 encode it. We're going to put it into the key store inside of that storage services storage helper again. And then finally, we update the account, which we'll look more closely at what this function does, but essentially all it does is take the public key, call the blockchain and say, hey, what's this account look like? What's the state of this? And this will actually set the value for this.account.state so that we can actually see that information. So we'll go ahead and create this account, put those same pin code again in. We'll see all that happen with the loading state. It's going to go to FriendBot, give us those 10,000 lumens. You'll notice that it popped in really quick. We didn't have this piece yet, but then it updated our account, and now we have this nice object which shows us the information about our account. And we go and we copy that address again. We go to Stellar Expert. We can see that we in fact have that account. And Stellar Expert is actually performing an identical call where it's just calling this right here on the account, this get function on some Horizon endpoint, and pulling the account information. So a lot of these services use all of the same endpoints. And so long as the blockchain is all synced, and that's the whole point of the blockchain, all that information will be identical. All right, so now we've created our account. We can move on to some of the functions and methods within the state once the account actually exists. The first two that we'll notice very up at the very top is we first put in this account.public key, which if you recall from create account, we loaded into public key right here. And I also think in component will load, we do the same thing if the key store exists when we pull it in. We're actually, before we decrypt it, we're actually pulling in that information from that A data that we loaded in. So I actually am using it, decrypting that base64, giving myself a JSON string, parse that into an actual object, grab the public key, put it in public key in the key store. So we're getting ourselves to the exact same state that this got us to whenever we refresh the page. Our first two buttons here, copy address, copy secret, copy address, nothing fancy in it. We're just taking the public key and copying it to the clipboard using the appropriately named copy to clipboard method or plugin, package, npm library, I don't know. And then the next one we do is copy secret. And this is where we're first going to get a good glimpse at how we do decryption of the secret key, because I don't store the secret key anywhere in the interface in raw format. It's all in a key store file, which we encrypted with our pin code. So if we look at our local storage, we should see this key store file right here. And this is base 64 encoded. So if we were to do a decrypt that base 64 and we actually put that, sort of do the same thing that we do when we refresh the page, we can get this object here. So this is that SJCL encrypted key store file right here. And that's what's used whenever we do any sort of decryptions. There's no secrets stored here. It's information. It's this key store file, which we can use our pin code to derive that secret key. And you can see this A data right here is another base 64. So if we show that, we'll get that public key that we had previously. All right, so when we copy the secret, we again only want it to do button type things. And the pin code is going to ask us, this prompter is going to ask us for the pin code. If there's no pin code, we just return, throw away any errors. And then we grab the secret. And this is again using the SJCL, but instead of encrypting, we're obviously decrypting. We put in that PIN code. We tell it what we wanted to decrypt. It's the key store file. And then it's going to pull out whatever we decrypted originally, which in this case is that secret. So we copy that, 1, 2, 3, 4. Okay. Now, if we were to paste that, you can see the secret key right there. Please don't copy and steal all of my testnet lumens. Okay, we've copied our secret. We can move on to the next one, which is, well, we've got trust asset and make payment. We'll get to those in a minute. We'll come back to that. I would like to first touch on just a update account, because that one's important. And then sign out, we're not even going to touch that one. All that one does is just throw away our storage items and refresh the page. But for update account, this is a Stellar specific one that makes one of our first calls to the server. And if you remember from when we loaded up our component, that server is a Stellar class with whatever Horizon API endpoint we're calling. And there's lots and lots and lots of interesting things you can do with the server. There's all kinds of, you can get accounts, assets, anything that's basically inside of Horizon that you're going to call that REST API endpoint. All of the gets are going to come from this server class. So we're just going to load up a server. And then when we click update account, we're going to load the public key. And then it's going to give us back an account object. That account object is going to have lots of information in it, all of this stuff. I am not showing all of this stuff because we don't need all of it for the purposes of our demo. Depending on the application that you're building and whether this is a client or a server-side application, you may want more or less of this data. You don't have to obfuscate or remove it, but I'm choosing to remove a lot of it just to make the interface a little less noisy. So I'm altering the balances and also putting the account back in and omitting a few of the other keys as well to leave us with just a nice clean balances object along with when it was modified last, because this timestamp changes anytime this account is modified. So, hey server, I'd like to load the account. Cool, here's the account. Sweet, I want to do some things with it. Ultimately setting the account state for the component, putting in everything else that we already have in the account, and then adding that state. And if you recall back from our wallet, we have this optional state key right here, which we can put in an account record from the server API. And that's exactly what we're doing here. We're loading in this state, this Stellar account. We stopped loading. We started loading the button right there. So we stopped loading the button regardless of whether it fails or succeeds. But if it does fail, we take that error and spit it out to the interface just like every other error. So that's what this update account button does. It pulls that in. If we look at our network interface or our network console here, we can see that these are in fact making requests out to the Horizon API endpoints and sending us back nice information about this account. I'm just choosing to pull in balance information and throwing out most of the rest of it. All right, so that's update account. Now let's start doing some interesting modifications, mutations, actually making and signing transactions. Let's start with making a payment. It's the easiest thing to do because we already have some lumens in here. We already have an asset that we can send. The easiest thing for us to do is just to go ahead and make a payment to some other address. So if we go to our render interface, you can see make payment right here. That's our make payment button, and it's calling a method make payment, which is this make payment.typescript file. This is going to start to look really repetitive and normal as we kind of continue on in this flow. There are a couple of different things here, if statements, because we may not always be making XLM payments. We may also be making payments to a custom asset, and there's some additional information that we need from our prompter if we're trying to make a payment to a specific address. I'm going to skip some of these. So we do have a prompter that's asking us how much of an asset we want to pay. So I'm going to go ahead and click this make payment. You can see that we've got this need to make an amount payment and then have a space and then an asset type. So that would be your, XLM or NFT or pizza token, and then the account that you actually want to send it to. So our prompter takes this information and from that information derives the actual kind of transaction that we want to generate, the operations that we want to put into our transaction. Because if you're making an XLM payment, it's a little bit easier than if you're doing a custom asset, because I don't have to ask about who the issuer is of Lumens. It's a native asset, and everybody already trusts it whenever their account is created. So how much asset do you want to pay? Well, we're not going to worry too much about this again, because this is if you trigger this programmatically. But if you trigger through the interface, this one's never even called. It just goes right to here, amount, asset, destination. And then it takes that, it splits it by the spaces in between. If the instruction's 1, so 0 index, 1 index, if the asset is XLM, and it's irrespective of its capital or lowercase, but if it's XLM, we can, if it's not XLM in this case, so if the asset type is not XLM, it's going to ask who issues this asset. If it's me, it's referring to yourself. So we have another one down here. If it's me, we just assume that it's the key pair's public key. Otherwise, if you have an asset, like in the case of our other account over here, if this account wanted to make a payment of its pizza, because it's got one pizza to start paying out, because it itself is not the issuer, right? These are different. Because those are not the same, it's going to have to put this in instead of saying me, because it's not the issuer. This is the asset issuer. Because an asset code is not the unique identifier. It's the asset code plus the issuing address that makes an asset unique, right? I could go out there right now and start issuing USD, but it doesn't mean it's backed by anything. That's why the TOML file becomes really important, where you can verify the identity of an asset issuer. Does that issuer actually have USD? Is it backed by anything? Just because an asset can be created doesn't mean it's necessarily trustworthy. But anyway, it's the combination of the asset code plus the asset issuer, which is why we have to, in some instances, capture that issuer unless it's XLM. Finally, after we've got that information out of the way of the amount and what asset and to whom, we can grab our PIN code. This looks super familiar. We just put that PIN code in. If there's no instructions or no PIN code, we're just going to throw or return without errors, but nothing good is going to happen. Then we take this key pair that we got from our PIN code, we decrypt from the key store file. So this instruction right here gives us a secret key, and then we use that secret key to generate our key pair. So if you remember from way back when we created our account, we used keypair.random. Now we're going to use keypair.fromSecret, which generates that same key pair, but instead of it being random, we're recreating what we had in the past from a secret key. And that allows us in the future to sign a transaction for it. So you have to have the secret key to be able to sign a transaction. That's where the whole cryptography parts come in. Next up, if we have instructions of 3 where you're sending a custom asset, we set that, if it's set to me, we just go ahead and set that instruction to the public key pair. Otherwise, we assume that nothing interesting is happening there. Remove any errors, set up our payment loading state, and then we go back into our server. We're going to load up an account into our server, and we're going to start transaction builder. So this one's pretty interesting. If we go back to our key pair or our key Stellar.js documentation, we can go to our transaction builder, and we've got lots of interesting construction items that we can add. pull that up here. You've got particularly the add operation is the one that we're going to be interested in, but there's a couple of different things you can do, building and signing transactions. What we want to do right now is build a transaction. So we load up our account, we take our account, we load that into the transaction builder. Transaction builder takes a couple of arguments. The first is the source, which the source is the source account. So this is going to be the source account of the transaction. So if we go back to our laboratory, for instance, when we're building a transaction, that's this this source account right here. Who's going to be paying the fee for this transaction? And how much is that fee going to be? What's the network passphrase? This is going to trigger a combination between the actual Horizon API or the Horizon base API base URL that you're on, along with the passphrase that you're using. So if you look up networks, I think they're down here somewhere. Networks.testnet. You've got all your networks down here, and it's basically just a toggle right now between public and testnet. So this would be the passphrase for the public network, and this would be the test network. And the reason that they have these is so that you can't take a test network XDR and submit it on the public network. When the actual XDRs are generated and the transactions are signed, you don't want a test network transaction being valid in the public network. And so those passphrases protect against that. Next up, we have our operation, and we only have one operation in the payment, and that's to operation.makeApayment. So if we look at our operations, it's just operation. We've got add operation right here, and it's going to add operations, and we've got a whole bunch of them. In this case, what we're doing is an operation.payment, and that takes a destination. Who are you paying? What are you paying them, and how much are you paying them? And then the source account would be, if the source account is assumed from the transaction source, it defaults to the transaction source. But if you wanted to be a fee signer, but you wanted to include a source account from a different account, you'd have to get their signature. But it gives you the freedom to kind of include a lot of different operations within a single transaction without them all having to come from the same source account. So destination instructions 012, 012, what's the destination? The assets, if there's 013, which the instructions for the fourth, there's a third index, but the fourth parameter there, if there is one of those, so essentially if we're doing a custom asset sale, do this asset, otherwise just do asset natives or XLM. If it's doing that new asset, it's going to be the asset name along with the asset issuer. And that's how you would create from this asset class here. New asset takes the code and the issuer. And then how much are you paying them? That's instructions index 0, which is that first amount. Set a timeout, which essentially means how long is this transaction valid for before it gets submitted? How long can somebody hold this transaction before it gets submitted? A setting of 0 just means forever. They can always submit it, and so long as it goes through, it's good. You could set that to 5 minutes or some timeout if you were including information that you only wanted to be valid for a short time. It's kind of like a JWT authentication token or something like that, where somebody could use this transaction to prove something, whether that's I'm allowed to make a payment or any other number of operations. You probably don't always want to set that to infinite, but for the demo, works fine. And then we build that transaction, which actually bundles all of these things together and returns an actual transaction object. So there's a transaction builder, which builds and outputs a transaction. And this transaction object or class has a lot of different methods on it. Oops, I've lost it. Right here, you can add your signatures to it, or in our case, sign it. You can turn it into an XDR, which is that human readable encoded version of the thing, the string that you can pass around to other people if need be. But for our purposes, all we're going to be doing is taking that transaction, signing it with our key pair, which we generated way back up here when we decrypted from the pin code and got our secret. Signs it, submits it to the network, walla walla poof, and we're off to the races. Submitted to the public network or the test network, and we've made a payment. I won't go back through that because we already did that initially. And the only other one that's left is trust. And I'll work through this quick so we can get to any questions that folks might have. But our trust asset here is very similar to that payment, where we've got some instructions from our prompter, asset, and issuer. We split those. We get our PIN code, decrypt, get our key pair again, and then we call back to our server and we say, load up the account, take the account, build a transaction, send in everything we did before. But instead of making a payment, we're going to do an operation that changes trust. And this essentially says, I, as this account, trust some other asset. I'm willing to add a trust line to some other asset from some other account. And that asset will be from instruction index 0 and instruction index 1. And it will add that trust line to our account. We sign it with the key pair. We submit that transaction to the network, stop all the loaders, and update the account again. So as you can see, there's really not a whole lot here. It's quite straightforward. I may have taken a while to explain it, but these things are super simple. In just a few lines of code, you are able to interact for free, essentially, for very, very low cost without setting up nodes or going through any configuration process. Through just very basic API calls, you can begin to interact with the blockchain, the Stellar blockchain network, making payments, trusting assets, issuing things, sending stuff around, doing that value transfer that everybody wants to be doing on a public decentralized ledger blockchain. I'm going to go ahead and open it up for questions that folks may have, and we'll take it from there.
Awesome. Thank you very much, Tyler. And yeah, everyone feel free to put any questions you have for Tyler in the chat. But yeah, there's a few questions throughout around the recording, but yes, this session has been recorded. So if you want to go back and rewatch it at any point, that should be uploaded on Monday. Additionally, in terms of questions throughout, I think Anchor managed to answer a few of them, but Marco asked, is there a repo of this wallet done before in React Native?
No, we have a few React repositories or libraries. I don't think any of them are in React Native, but all of these functions can be picked up and dropped into something like React Native very easily. It's one of the reasons that I wrote it in Stencil.js, is it's quite easy to just take these TypeScript files, these TypeScript methods, and move them around to any other thing that you might need.
Awesome. And Anchor did post a kind of link to the different SDKs that Stellar have, so I've just reposted that in the chat as well. There's a bit of discussion about Blockchandrous, who's developing for the hackathon actually a Stellar SDK for Node-RED, which is a few people have seemed interested in that. So it'll be interesting to see that as well. But yeah, I think that's all the questions we have from the audience, unless anyone else wants to put any more in last minute. But thank you very much, Tyler, for your time today and the fantastic workshop, and also Anchor for helping out with some of the questions in chat. Just as a reminder, we do have the final kind of session in the sponsor workshop series, which are, I'll just link that there, which is with CoinMarketCap and Sandbox. And yeah, we're looking forward to see what everyone builds on Stellar.
I'd like to call out just really quick before we bounce. As people are interested in learning more, I have a game that I've developed, an educational platform, Stellar Quest. So if you go to quest.stellar.org, it's a bunch of code challenges that you can do to learn about Stellar at a very technical level. We've actually got a new series of challenges going live, which will have XLM prizes. So you kind of have the opportunity to turn on a little XLM faucet for all those developers out there. So keep an eye on that space. We've got a Discord. Go ahead and complete series 1 and 2 that are already available. It's a great place to learn Stellar at a technical level and win some cool badges and XLM as well.
Awesome. And we have a question actually from Linux Lover, who asked, can we produce a QR code with a transaction included?
Yeah, absolutely. I mean, a QR code at the end of the day is just an image of some string. So you'd probably want to turn your transaction. You would want to turn your transaction into something like an XDR, and then turn that into a QR code that somebody could scan. There's very similar to a lot of other blockchains. There are proposals to the core infrastructure and how that's updated, and then also consensus around how certain things are done. And this idea of passing transactions or unsigned transactions, like how can I generate a transaction and then pass it to you so that you can get it signed? A QR code is a great way to do that. And there's what's called a Stellar Ecosystem Proposal, a SEP. And if you look up in our repo for ecosystem standards, you should be able to find the SEP where the idea of encoding transactions both into URLs and QR codes is handled to ensure that that transaction is handled appropriately and passed over in a way that's able to be read and signed by some third party.
Fantastic. Well, thank you everyone again, and thank you very much to Tyler for your time this evening. I hope you all have a fantastic weekend, and we'll see you on the next event.
Thanks all. Bye.